Dominica State College Math 1-to-1 Final Assessment, Section A, Practice Questions number 4. It says a researcher was interested in the relationship between major and mathematics score. All right, your academic major and your mathematics score. He hypothesized that there was a relationship between the variables academic major and mathematics score. So that's what he said, that there is a relationship. For this objective, the data is represented in the following table. You are given the task of testing his hypothesis by using the following data. Here you've got a contingency table. That's a two-way table. And for example, it says 49 students from the natural sciences scored below 50%, whereas from the same natural sciences, 101 scored above at least 50%, whilst in the social sciences, 75 students scored below 50%, and from the same social sciences group, 75 students scored at least 50%. So we've got a chi-square value of 3.81, and we are going to use that in conjunction with week 9, weekly list number 9, unit 9, to solve this question. So we go to the Google Classroom CI3QYBO, we go to classwork, and then we move to weekly notes, Word, PDF, PowerPoint video format. We check out the PDF format. Week 9 is on hypothesis testing, and we can check out an example in there. So example 9.6 is a chi-square test, is an example of a chi-square test for independence. Okay, and here now we have our two variables, your central, your residential area, and your performance. So is there an association between residential area and performance? So we've got our pair of hypotheses. The first step is stating a pair of hypotheses. The null will be saying independent, no association between the two, and the alternative will be saying dependent. Okay, there is an association between the two. Okay. Now, the second step, you've got a chi-square curve, which is right, skewed to the right, and your rejection region, which is on the right, and the critical value on the critical point, which is on the right. So we've got our steps number 1, 2, and 3, and we can actually do that in our example. So here we've got our null and alternative. The null, as we know, will be saying no association between the two variables, and the two variables are major and score. So the null will be saying there's no association between academic major and score, that they are independent of each other. And the alternative is saying that there is an association between academic major. The one is dependent on each other. Then we've got our skewed curve to the right, our rejection region on the right, and our critical value on the critical point. So step number 5 says we're going to calculate the expected values, because the values that are on the contingency table are the observed values. So the expected value is the row total times column total divided by the grand total. And then we can use this now to calculate the chi-square contributions to find the sum thereof to get the chi-square test statistic. So here's an example of how this was done. You have here you have the observed values, and then the row total and column total and the grand total were used to calculate the expected values. And then we have used this observed and expected to calculate the chi-square contributions. The sum of the chi-square contributions will give us a chi-square test statistic. So let's do this in our example. So here we have the contingency table with the 4 observed values. The observed values are 49, 101, 75, and 75. Now we have to use the formula row total times column total divided by grand total to find the expected values for each observed values. Here we have the totals, the row totals, and the column totals, and the grand total. The grand total is 300. So therefore now, so for the expected value for 49, that would be equal to 150 times 124, because 124 is the column total, divided by the grand total, Okay. For 101, that will be equal to the row total, which is 150, times the column total, which is 176, divided by the grand total, which is 300. For that 75 right here, that would be the expected value would be equal to the 150 row total times the column total, which is 124, divided by the grand total, which is 300. And for this 75 here, that would be expected value would be equal to the row total, which is 150, times the column total, which is 176, divided by the grand total, which is 300. So here we have our expected value, and the chi-square contributions will be equal to O minus E all squared divided by E. As you can see, they are all calculated, and the sum thereof will be the chi-square test statistic, which is 9.29 in that case. Now, according to the example, after the chi-square test statistic has been calculated, it has to be plotted on the distribution curve with reference to the 0 and the critical value that are already there. So our chi-square test statistics of 9.29 is actually greater than 3.841. So you have to go to the right of 3.841. Anywhere to the right suffice. So here we have plotted our chi-square test statistic. And as you can see, it is located in the rejection region. Now recall for decision time, it says reject the null if the test statistic is located in the rejection region or the shaded region. And you do not reject the null if the test statistic is located in the unshaded region. There are two types of errors that can be made, type 1 or type 1, 2, or type 2. Type 1 occurs if the null is rejected and it is true, and type 2 occurs if the null is not rejected and it is false. So now our test statistic is in the critical region, so we have to reject the null. So we may have committed a type 1 error because we are going to reject the null hypothesis, and it could be true, okay? However, we would not know because we are making this decision based on the data collected. So therefore now, for step number 7, for decision time, we are going to reject the null hypothesis. So again, as we can see, our test statistic is in the critical or rejection region. So therefore, we have rejected the null hypothesis. Finally, conclusion time. It says if the null is rejected, then the alternative statement is the conclusion. If the null is not rejected, then the null statement itself is the conclusion. Always remember that you will start the test with two statements, the null and the alternative. After the test is done, only one will be the conclusion. Write out the conclusion in verbal form, in written form, in worded form. So now we have rejected the null hypothesis. So therefore the alternative statement, that's what we are left with. So we have to quote it as our conclusion, the alternative hypothesis. So here we are going to quote the alternative as our conclusion, and it is saying that there is an association. So that's it. Based on the data, there is an association between academic measure and mathematics score.